Welcome and thank you for joining. Let's take a look at a homework question from the textbook, page 83, number 18. So in this question, we're asked to determine the value of A, given that the line y equals ax minus 4y plus 21 equals 0 is tangent to the graph of y equals a over x squared at x equals negative 2. So let's get started by jotting down the information. So what we are given in here is that the tangent line will have the equation ax minus 4y plus 21 equals 0. Now this tangent line is drawn on the graph of y equals a over x squared exactly at x equals negative 2. So what we are missing in both equations, as you can see, is the coefficient a. So in order to find the coefficient a, we have to look closer into the connection between the two pieces of information given. So we are given a function, and we are given the point we're drawing a tangent, and we're given also the equation of the tangent. So we need to find the connection between the equation of the tangent line given with the equation of the tangent line drawn at x equals negative 2. So I will start off by discovering the equation of the tangent line drawn at x equals negative 2. And then at the end, what we'll do is we'll compare the two tangents together in order to find the missing coefficient a. So step number 1, find the equation of the tangent drawn at x equals negative 2. The equation would be something in the form y equals mx plus b in slope y-intercept form. And what we do know about this tangent line is that the x value would be equal to 2, and the y value will be the value of the function at negative 2. So which makes the y value equal to a divided by negative 2 squared, or a divided by 4. So all we know so far are the y value, a over 4, the x value, negative 2. We still don't know the slope, and we do not know the value of the y-intercept. So these are going to be our two unknowns for now. So we'll start off with finding the slope. We know that the slope would be equal to dy dx, or the derivative of function y. As you can see here, the function here is given in rational form. We've only learned how to differentiate powers. So before we start differentiating, we'll change the format of the equation. So we'll write it in power form, which will be simply ax power of 2, bring it to the numerator, change the sign to negative, so ax to the power negative 2. So what we are trying to do in here is differentiate ax to the power negative 2. And by simply using the power rule, we'll have here a. The coefficient of x will become negative 2. And the power of x will reduce by 1. So negative 2 minus 1. So therefore, we're going to have the derivative equal to negative 2a x to the power of negative 3. So in a more simplified form, we would say that this would be negative 2a over x to the power of 3, and this would be the slope at any point x. Now remember that we already know where we are drawing the tangent line, which means that the slope of the tangent line drawn at x equals negative 2, I'm going to write that down here, would be equal to negative 2a divided by negative 2 to the power of 3. So that will give the slope of the tangent negative 2a over negative 8 equal to a over 4. So the slope of the tangent line on the graph of the function given would be a over 4. So we're going to go back to the equation we were working with, and we're going to say, you know what, we have great news. We found the slope. Let's substitute everything we have, and let's see what the equation of the tangent looks like. So for the value of y, remember that we found a over 4. So we're going to say y is a over 4. The slope is also a over 4. So we'll write that down. The value of x is negative 2. And the value of b is still unknown. As you can see here, we are missing b, and we are going to find b in terms of a. So we have a over 4 equals negative 2a over 4 plus b. And take negative 2a over 4 on the other side. That becomes positive. And it seems that the value of b became 3a over 4. So therefore, we're going to say the equation of the tangent line drawn on the graph of this function will be y equals the slope of a over 4. Remember that we found the slope of a over 4 from the derivative here, right? And we substitute it in here. And then times x, and then plus the coefficient 3a over b. Let's be consistent with the colors. So as you can see, we just obtained now the equation of the tangent line drawn on the graph of the function at x equals negative 2. Now, we are told that the equation of the line, of the tangent line, is ax minus 4y plus 21 equals 0. So it's time for us to now compare the equation of the tangent line with the equation of the tangent that we just found. And when we compare two things, we need to have them in the same format. So we compare apples to apples, oranges to oranges. And you can keep on going and use all the fruits and vegetables you want. All right, so here we go. We're going to write this in slope y-intercept form, which means negative 4y will stay on the right side, on the left side, and then we get negative ax and then minus 21, which will give y equals a over 4. So divide by negative 4 every term. And that will give y on its own. Negative and negative will simplify to positive a over 4x plus 21 over 4. So now it's time for us to grab this equation of the tangent line given and compare it to the equation that we found by finding the derivative. So as you can see in here, the slopes are the same, and that makes sense because we're talking about the tangent line, same tangent line drawn on the point of the graph, on a point at x equals negative 2. So the y-intercept that we were able to find was 3a over 4, and the equation given has the y-intercept, the actual value of the y-intercept. So this is the part of the equation that will be useful to us in our case. So we're going to say we have to use the given y-intercept from the equation of the tangent that was given to the equation of the tangent that we found. So we're going to say that 21 over 4 must equal 3a over 4. So therefore, we're going to say that by multiplying both sides by 4, you can see that 21 equals 3a, which will make the value of a equal to 7. Therefore, we're going to say that for the tangent line to be in the form ax minus 4y plus 21 equals 0, drawn at x equals negative 2 on this function, then the value of a has to be equal to 7. I hope that you found this helpful, and thank you for watching. Bye for now.